So we're going to look at another example of solving this differential equation, y prime dy dx if you want equals 2xy, using a power series.
That'd be fantastic.
Oh, great. So anyway, we assume a solution that's a power series, center at 0, and substitute in the equation. Now we're only going to need one derivative for this one. So y prime, derivative of a0 is 0, derivative of this term is a1, the derivative of this term is 2a2, x, derivative of the next term would be 3a3 x squared, etc. And you can see how that's going to go. Well, anyway, that's on the left side of our equation when we substitute here. There it is, right? And then plus 2 times x times that power series that we assumed was the solution. And so a1 equals 2a0x. Well, you can follow that on down the line. And because of this, you can see that this a1 must be 0, because this whole thing, there's no corresponding term on this side without having an x in it. So therefore our a1 has to be 0. Our a2 has to be the same as, our x term has to be the same as this term, so a2 and a0 are equal to each other. And then for a3 we got, let me see, 3a3 x squared. Over here we have 1x squared, 2a1x squared. So 3a3 equals 2a1, so a3 is 0, because remember a1 was 0, duh. Matter of fact, every other term is going to be 0 from now on. So then we also want to plug in our a cubed term. So there's our a cubed term, 4a sub 4, and our a cubed over here is 2a sub 2, so these two are equal to each other. But a2 is the same as a0, and we know that that makes the a4 1/2 of a sub 0. You can see that it was a half of a2, and therefore a half of a0. Similarly, we can go on and get some more coefficients. And so our power series solution, y equals a0 plus a0 x squared plus a0 over 2 x to the 4th plus a0 over 6 x to the 6th. So that only has one constant, but look, back at the original equation, we only need one constant, we only have one derivative. So this is our solution, a0 factored out of each of these terms, 1 plus x squared plus x to the 4th over 2 factorial plus x to the 6th over 3 factorial. I called it, 6 instead of 3 factorial, but then you could follow that pattern, and you should recognize that that is the power series for e to the positive x squared. So the solution is really y equals a e to the x squared. And so that one is 1. Just to show you get the same result, we can do that one by separating the variables. See, dy dx equals 2xy. So separate the variables, dy over y equals 2x dx. So that means ln of y equals x squared plus c. That means when you do e to both sides, e to the ln of absolute y is the absolute value of y. And on this side we have e to the x squared times e to the c. And that e to the c, I'm calling it c prime, so then we wind up with, oh, by the way, the prime lets us drop the absolute value symbols, or the c prime there, because we don't know, it's just an arbitrary constant, so that lets us drop the absolute value symbols, so y equals c prime times e to the x squared, and that is the power series we got when we tried the power series method to do that. So how about that? So anyway, we'll use what we know from power series for this example in the next lesson. You excited about that?
Uh-huh.
Okay, great.